Hi, and welcome back to the next part of lesson 8. In this video, we're going to talk about something really important. In statistics in general, something that we really want to be able to do is interpret things, make a real world interpretation. Calculation is important, graphing is important, and interpretation is also really important. So we're going to make interpretations of the correlation coefficient R and a new one called the coefficient of determination, R squared. So the first thing we want to be able to do is calculate them. Correlation coefficient is R again, and the coefficient of determination is R squared. We're going to use this example from the previous part. So same way we calculated or generated a scatter plot, we can calculate R and R squared by putting the data in, and then we'll do something called a linear regression. And there's actually two of these, and they do the same thing. But one way you can get there is hit the Stat button, arrow over to the Calc menu, and then choose option 8, lin reg a plus bx. And then you'll tell the calculator where the x values are and where the y values are. So it doesn't have to be L1 and L2, but that's where you put them, and that's what you put. This store reg EQ is a way to put the regression equation into your graphing system automatically. So you can do that if you want. It's really cool. You don't have to do it though to get the answer here. But if you want to do it, it's optional. You click vars. You'd have the cursor right here, and you'd click vars, y vars, function y1, or any of the y options, but y1 is probably where you want it. So this step right here is optional, but it's cool. And then you go to calculate and hit enter, and it gives you a screen like this. And a linear regression is just a y equals mx plus b. Unfortunately, instead of mx plus b, we have a and b. But basically, it's a slope offset formula. And I don't know why it does this, but it tells you y equals a plus bx, and then it says a and b equals these numbers. It would have been cool if it just said y equals and gave you the equation. But basically, you just substitute this number in for a in whatever it's giving you, and substitute this number in for b. So in this case, b is the slope of the line because it's attached to the x, and a is the y-intercept value. That's not really what we're after right now, but we will later. What we wanted right now is R and R squared, and so that also shows up here. It probably won't the first time you do it, because for whatever dumb reason, the TI-83 and 84 calculators come with this feature turned off by default, so you have to turn the feature on. It will stay on until you do like a factory reset, and that will turn off again. So if you don't see R and R squared in the output, you're going to click the mode button, scroll down and find stat diagnostics and turn it on. So I didn't think the screenshots showed it very well, so I actually going to pull up a actual calculator emulator and show how to turn it on. What you're looking for is this mode button, and there's a lot of things in here that you can do, but what you're interested now is if you scroll down with the arrow. I'm sorry, the emulator is very laggy. If you scroll down, eventually you'll see this thing that says stat diagnostics, and you want to arrow over to the on and hit enter, and then you can quit. And now it's turned on, and then you would do the lin reg again. I also want to point out one other thing while I'm here. If you hit stat and go over to calc, option 4 also does a lin reg, and it's ax plus b. It also works. It just swaps a and b. I don't know why they've done this. It's very odd. Let's just scroll down. So option 4 and option 8 do the same thing, but in the output, a A and B will be switched up here, and A and values of A and B will be, these actual numbers would be swapped. So you just have to look at the way that it's writing the output and just put in the value of A for A and put in the value of B for B, however you do it. Okay, let's continue. See, where were we? Oh, if you don't have an 84, if you have an older calculator, when you get into this, you might not see this menu system. If you don't see this menu system, you just have to know the order, what it's expecting. The order it's expecting is the X values, the Y values, and then optionally where you want the equation to go in the calculator. Same thing, it's probably turned off by default on your 83. If R and R squared are not showing up on the 83, you'll need to find it a different way. Oops. And the 84 can do it too. So you can do this on the TE-84 as well. Down here above the 0 button is catalog. So you hit the blue thing and access the catalog. And this is basically an A to Z list of everything your calculator can do. So you would scroll down. Oh, this is gonna be painful. I guess I need to go slower. And you're looking for a thing called diagnostic on. Yeah, I apologize, it's a laggy emulator. I can't go any faster. Okay, we got it. Diagnostic on, and you hit enter, and it seems like it maybe did something, maybe it, I don't know, it didn't, but you have to hit enter again. So we've called up the menu option, and we hit enter again, and it says done. So that's something you only need to do if you're not seeing the R squared in R. Once you turn that on, it will stay on until you do a factory reset, or like if your batteries die for a while. Yeah. Okay, so let's finally interpret these things. For this data, this is the violent crime data. The correlation coefficient is very strong. We have a positive correlation because it's a positive number, and it's strong because it's above 0.7. So in English, we would translate this to say there is a strong positive correlation between the number of people and the crime rate. So we're just going to mention the strength and direction. The words that are underlined is kind of like what you should put in. You can use this sentence as a template. And you're going to put in the direction and strength. And then in the other two things, you just describe the variables. This one is the coefficient of determination. And how we interpret these is really kind of interesting. You can turn this into a percentage and say that blank percent of the variation in the Y variable can be explained by the X variable. So the template is down below, the underlined things and what you put in there. And in this example, 96.31% of the variation in crime rate, that was our Y variable, can be explained by the number of people. So that's pretty strong statement. Not too surprising. The more people, there's going to be more crimes, but maybe surprising just how strong it is. All right, we'll see you in the next video.